Welcome to Prof.Ahilaa Maths, Plus 2 Mathematics, Tamil Nadu State Board Syllabus, Chapter 1, Application of Matrices and Determinants, Video 1.6, Assignment 1.2, Exercise 1.1, 3, 4, 5 problems. Exercise 1.1, question number 3. If f of alpha equal to cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha, show that f of alpha the whole power minus 1 equal to f of minus alpha. We need to prove f of alpha inverse equal to f of minus alpha. That is, the inverse of f of alpha equal to f of minus alpha. The simplest way is to find the right hand side first. That is f of minus alpha. So given f of alpha, to find f of minus alpha, we need to substitute alpha equal to minus alpha in the given matrix. When we substitute alpha equal to minus alpha, we need to get some values using the odd function and even function concept. Okay. So if f of minus alpha equal to f of x, then we say f is an even function. If f of minus x equal to minus of f of x, then f is odd function. In trigonometric ratios, sine, cosecant, tan and cot are odd functions. Only cos and secant are even functions. So cos of minus alpha equal to cos alpha. Sine minus alpha equal to minus sine alpha. Using these values in the given matrix, we get the right hand side f of minus alpha equal to, put alpha equal to minus alpha in the given matrix. Cos minus alpha 0, sin minus alpha 0, 1, 0, minus sin minus alpha 0, cos minus alpha. Therefore, f of minus alpha equal to, substitute the values of cos minus alpha and sin minus alpha here. So, you will be getting cos alpha 0 minus sin alpha 0, 1, 0. Sin alpha 0, cos alpha. First method. Actually, this is the brilliant method and simple too. Now, we need to prove f of alpha the whole power minus 1 equal to f of minus alpha. That is, inverse of f of alpha is f of minus alpha. We know by definition of inverse, a into a inverse equal to a inverse into a equal to in. So, here you forget that minus 1. So, the inverse of f of alpha we need to prove as f of minus alpha. So, when we product f of alpha and f of minus alpha, we need to get the identity matrix. That is the idea. So, we need to prove f of alpha into f of minus alpha equal to f of minus alpha into f of alpha equal to I3. So, I get the value of f of alpha into f of minus alpha. Already f of alpha is given, and from the right hand side part you know what is f of minus alpha. We substitute both the values and get the product of these two matrices as below. So now seriously you can find it that you are getting 1 0 0 0 1 0 0 0 1, that is identity matrix of order 3. And you are using the identity value in trigonometric ratios, sin square alpha plus cos square alpha equal to 1 in here. So thus similarly we can prove that that part f of minus alpha into f of alpha also we will be getting I3. Thus the product of f of alpha and f of minus alpha gives the identity matrix. We can say the inverse of f of alpha is f of minus alpha. Thus, we are getting f of alpha the whole power minus 1 equal to f of minus alpha. Got it? Fine. The other method is the usual way of finding inverse. You know the formula A inverse equal to 1 by determinant A into adj A. Here instead of A, we are having f of alpha. So, we need to find the left hand side f of alpha the whole power minus 1 equal to 1 by determinant f of alpha into adj f of alpha. This is a long process. So, better to use the previous method, that is the brilliant way. So you need to get determinant f of alpha and simplify. You are getting the value as 1. Ensure that it is not equal to 0, then only inverse exists. Here it is 1, so it is not equal to 0, f of alpha the whole inverse exists. Then find edge f of a, that is the transpose of the cofactor matrix of f of alpha. As usual, you get the values of edge f of alpha. Then you substitute in f of alpha the whole power minus 1. That is, we are getting cos alpha 0 minus sin alpha 0 1 0 sin alpha 0 cos alpha. So thus we get that these are left hand side and right hand side are both are equal, so that we can say that f of alpha the whole power minus 1 equal to f of minus alpha. My kind advises that better to use the first method. Hope you have got it. Now the fourth problem is, if a equal to 5, 3, minus 1, minus 2, show that a square minus 3a minus 7i2 equal to O2. Hence find a inverse. Here a square means a into a. I2 means 2 by 2 identity matrix, and O2 means 2 by 2 zero matrix. Let's see the proof. Given A equal to the matrix 5, 3, minus 1, minus 2, we need to prove A square minus 3A minus 7 I2 equal to O2. Now for that we need to get the value of A square, multiply A, and you are getting A square as 22, 9, minus 3, 1. Now we need to get the left hand side value. Substitute the values of a square, a, and I2 matrices in the place, so that we are getting a square minus 3a minus 7 I2. Substitute in the places and simplify each element by normal addition and subtraction method, so that you are getting all the values 0 in the simplification. Thus we are getting a 0 matrix of order 2, so that it is proved a square minus 3a minus 7i2 equal to O2. So in the fourth question, there is another question. See, hence find A inverse. Hence means we need to apply the previous proof, that is show that a square minus 3a minus 7i2 equal to O2. We have proved that result. Using that result, we need to get A inverse. Don't use the normal method here, okay? Since the word given hence find A inverse, we need to use the previous proof, that is whatever asked in the question to prove. From that result we need to get A inverse. Let us see how to get that. We need to find A inverse using the given show that result. Okay. Now we are getting that we have already proved that a square minus 3a minus 7i2 equal to O2. So post multiplying equation 1 by A inverse, we are getting a square into A inverse minus 3a into A inverse minus 7i2 into A inverse equal to O2 into A inverse. So whenever we multiply with the same basis, we will be adding the powers. So that like that also you can simplify, so that we can get a square a power 2 minus 1, that is a power 1. Like that also you can simplify. Otherwise use the associative law of matrices. So you can associate one of the a square a from a square with the a inverse. Thus we are associating like this. See the step: a into a into a inverse minus 3 into a inverse minus 7 into I2 A inverse equal to O2 A inverse. You know A inverse is I2, and so we are getting A into I2 minus 3 into I2, and whenever we multiply with the identity matrix, the same matrix remains. So 7 A inverse, and whenever we multiply with 0 matrix, we will be getting again 0 matrix. So O2. Now see A minus 3 I2 minus 7 into A inverse equal to O2. From this equation we need to get A inverse. So see the yellow marked A inverse. I am keeping A inverse in one side, bringing all the terms to the other side. I get 1 by 7 into A minus 3 I2. So substitute the value of A matrix in the place and I2 there, and simplifying you will be getting 1 by 7 into 2, 3, minus 1, minus 5. This is your A inverse. Now let us see the verification, how we are getting whether we have got the right answer for A inverse. There are two ways, okay. So by using the definition and by using the direct method of finding A inverse, whichever is easy, you can follow that. So A into A inverse, we know it should be IN. So we are getting A into A inverse. A, you know the given matrix, and A inverse, whatever answer you have got, and you multiply, and when we simplify we should get the identity matrix of the order 2 here. Thus we are getting, so we can say that our answer is right. Similarly, you can verify. In other way, since it is a 2 by 2 matrix, it is easy to use this method, direct way of getting the inverse, that is A power minus 1 equal to 1 by determinant A into adj A. So you can directly substitute 1 by determinant A, and you can get the adj A as interchanging the main diagonal elements and changing the sign of the other two elements. You can easily substitute it here, and you are getting the value 1 by 7 into 2 by 2 matrix 2, 3, minus 1, minus 5. In both the cases, it is verified, so our answer is right. Now let us see the fifth question. If A equal to 1 by 9 into a 3 by 3 square matrix minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4. Prove that A inverse equal to A power T, that is A transpose. We need to prove A transpose is the inverse of A. Here also we can use two methods. We can use the definition by definition and as well as direct way of finding A inverse. So I told that using the definition method is a brilliant method. So I here try with the brilliant method. It is your choice. You can prove in any way. Okay. So let us see the solution. Given A equal to 1 by 9 into that given matrix minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4. Now we need to prove A inverse equal to A transpose, that is to prove A transpose equal to A transpose A equal to I3. I prefer the brilliant answer. Now for this we need to get A transpose first. Okay, you know how to get the A transpose. The 1 by 9 is common to all the elements here. We keep that 1 by 9 as it is and invert the matrix given. So the rows and columns interchange, so that I am getting A transpose equal to 1 by 9 into minus 8, 4, 1, 1, 4, minus 8, 4, 7, 4. Now by definition I am trying to get A transpose. I substitute the value of A and A transpose and I am trying to get the product, okay. Now I am getting the product of A and A transpose. So I am multiplying 1 by 9 into 1 by 9 and I get, by using the product of matrices I am getting the value as 1 by 81 into 81 0 0 0 81 0 0 0 81, and when I divide by 81 in the interior elements I will be getting the identity matrix of order 3, 1 0 0 0 1 0 0 0 1. Thus similarly we can prove that the other part A transpose into A is also I3. So I am getting A inverse equal to A transpose. Got it? Now another note you have to mind, that is if A into A transpose equal to A transpose into A equal to I3 or IN, then A is an orthogonal matrix. This is the condition for orthogonality of a matrix A. Now video 1.7 contains all. Theorem 1.8, Theorem 1.9. Stay tuned. Success is ours. Thank you, my dear children.